Hello guys, welcome to today's class. Today we are going to cover another topic of machine learning, which is gradient descent, which is very important in machine learning and deep learning. The agenda of our today's class is to understand the intuition behind the gradient descent. What is gradient descent? Why is it important? And its practical application. It's what are the important key components of gradient descent. And at the last, we will do some practical implementation in Python of gradient descent. So let's dive into the intuition behind gradient descent. Uh, I hope you can see the diagram, and let's imagine you are standing on a mountain and wanted to reach the valley, where valley is the minimum point where you can see the river is flowing down. So where you can expect a river, and suppose you are very thirsty and you can feel the steepness of the slope when you look around from the top of the mountain. So, as you are very thirsty and you want to reach the valley quickly, instead of using a roadway, you thought of taking small steps in the direction of the steepest slope, because while you are on the top of the mountain you can just see around and you know that where is the steepest slope, because there you can reach the river more faster. So this is what gradient descent does. The gradient descent algorithm guides us in minimizing the distance, where our distance is cost function, and the another key component, which is the learning rate, helps us determining the size of the step to be taken in a particular direction. Because why it is important to just be careful about the size of the step we are taking, because suppose if we take large steps on the hill, we will never reach the minimum point, instead of hurting ourselves and by falling down. Therefore, if we take, and also on the other hand, if we take small enough steps, we might drain ourselves completely before reaching the river point. Therefore, it is important to mind the steps, where to keep large steps and where to keep the small steps. So here, from this example, we have understood that the the important thing what gradient descent does is guiding us in minimizing the distance, and the another key component, learning rate, help us in determining the size of the steps that we should take while implementing the gradient descent algorithm. So now let's further understand in a technical way what gradient descent is. So it is an optimization algorithm which we use to minimize the cost or loss function of a model. Why it is an optimization algorithm? Because it gives us the perfect and best parameters W and B with minimized cost. So the main idea is to iteratively adjust the parameters in the direction of the steepest descent of the cost function. Why is it important? Because it is the fundamental optimization technique, and it is the efficient algorithm that we can use to minimize the cost function by using the perfect or best parameters W and B, where W is our slope or coefficients and B is our intercept. It enables efficient learning of model parameters even for complex models with large data sets. Now let's see what are the applications of gradient descent. So in case of linear regression, we use gradient descent in minimizing the mean squared error between predicted and actual values. For logistic regression, we use gradient descent in minimizing the cross entropy loss function. While in neural networks, we keep on updating the weights and biases to minimize the error during training. of the model. There are three important key components of gradient descent. So there are three components of gradient descent. The very first one is cost function, the function we want to minimize by adjusting the parameters. The second one is the derivative, or we can say the partial derivatives of the cost function with respect to each parameters. And third one is the learning rate, and it is the hyperparameter that determines the size of the steps we take in the direction of the gradient. Now let's deep dive into the gradient descent algorithm, how it works. So basically what happens in case of linear regression, while training, we train the model so that it can learn the values of M and C. And the best values of M and C are the one where cost is minimum. So here you can see this is our linear regression equation for one variable, and these are the parameters that we have to find out, and this is the cost. So the cost function that we use in linear regression is the mean squared error, where yi is our observed value, y hat is the predicted values, and the difference between the two is the error term. We are squaring them and taking the average of that. And gradient descent is the algorithm that finds the best fit line for the given training dataset. How does it work? The most common function that we use as a cost function is mean squared error. It is widely used for regression equations, and the formula is 1 by n summation of yi minus y hat raised to the power 2, where yi is our observed value and y hat is the predicted value, which can be written as mx I plus b, and we are just taking the difference of these values, squaring them and taking the average by dividing by n. So this is the mean squared error that we use as a cost function. Now to find out the most appropriate values of m and b, so we can't just manually compute these values of m and b. So therefore we use gradient descent algorithm, which iterates through the entire training data set and returns the most appropriate values of m and b with cost minimized. So now let's see how this algorithm works. So you can see the diagram where I have plotted cost function with parameters m and b. I have taken these values as 20, 40, 60, 80 for m and different values of b. So we will be starting with this value where our m, let's say it's there is some value of m and some value of b, where the cost where the MSE value is the highest, and let's say it for this value of m and b, for this combination of m and b, our best fit line would be this straight line. Okay, then what happens, then it iterates itself again, and then it keeps on reducing the values, keep on reducing from this point to this point, and here we can see our cost is getting lesser, which can be seen by this particular line. So this so by keep on combinations of values of m and b, it keeps on reducing, and these are the different straight lines which we get for the different combinations of m and b. And this is our best fit line. We can see from the graph that this is our best fit line where our cost is minimized. So for this combination of m and b, where our m is say 60 and b is 0, so for when we are going to plot this value, let's say x 6x plus 0. So suppose if our value of our x is 1, then our y value would be 6. So this is how the predictions being done. Now let's understand the learning rate. So see, we keep on reducing our value, or for different values of w or say m, we keep on reducing our cost function. But if we are taking a very big steps, then we will never ever reach to the minimum cost, because see, we are taking same size of steps again and again. So to reach at this point, we would need a smaller step, otherwise it will move forward and keeps on changing the values of w, but they will never reach to the minimum cost. And what happens when we take very small steps? It will take a lot of time to reach the minimum point. That's why we use the learning rate, because by passing the value of learning rate, we define that where to take the larger steps and where to take the smaller steps. Because initially, if we take larger steps, that will help us in reaching the minimum point a little more faster. And then when we are almost there, we start taking shorter steps to reach the minimum point. So this is where learning rate helps. So learning rate helps us in taking the steps, that whether we should take the larger steps or smaller steps. But how do we get to know that in which direction we should move? So this is where partial derivatives helps us. So here, if we are considering only w, we can see if we are taking the larger steps. Okay, first step we have taken this step we have taken, we'll find out the derivative. Like by derivative I mean the slope, the tangent. And if it is steeper, then then it would know, the algorithm would know, understand that it is still steeper, I need to take more larger steps. And once it reaches at this point, then you can see from the diagram that my slope is getting a little more flatter. That means my slope is getting reduced, and I have to keep reducing my slope till it reaches at a minimum point where the value of the slope is 0. So that's how once it reaches this point, it will start taking smaller steps in this direction and keeps on moving by taking smaller steps till this point where it converges. That means where the value of the slope is 0, or the tangent line you can see is flatter. So at each point we calculate the slope of the curvature. That means for each value of w and b, we calculate the slope, which gives the direction. And what do we mean by slope? So this you have already seen for gradient descent. We are plotting, we are taking cost versus w. or any of the parameters that we are going to find out. So here this tangent will be delta c by delta w. Okay, so this is the slope here. So these are the steps and these are the parameters that we initialize uh, in the gradient descent. So these the value of m and b, they keep on updating until convergence. So till we reach this minimum point, the values of this w or b will keep on reducing, keep on updating, reducing or increasing. If we are here, then it will keep on reducing. Okay, so all it depends that initially what would be the value of w that we are passing. So here this m is the initial value that we are passing or we are considering from where we will start converging, and this value of b is also uh, that we are initially the value that we are initially passing, and this value, these values are the new values. This the value of this parameter lambda we will pass. It could be something very small value we will be starting with. So it's a hyperparameter. We keep on changing the value of lambda and then test it out, which is the best value of lambda that is giving us the best parameters with the minimum cost value. So let's say if I'm passing the value of parameter lambda, say 0.001, so this will be initialized. And how do we calculate the value of this derivative? So let's see that. So this is how we are finding out the values of derivatives. Here you can see this is our cost function, this is our cost function, this is y hat. So we are just taking the derivative of this cost function, partial derivative with respect to m and with respect to b. So you can just see how the derivative calculations I have done. So once the value, so this is the initial value, this is the initial value of w that I am taking, and then we'll check the slope at this value. So if it's steeper, that means this value is higher, then I still have to take a bigger step, and this value will be multiplied by the value of lambda, which could be 0.0001, and we are just deducting this value from w1 and we'll get a new value of w. So the new value of w could be this, and again we will check the slope at this point. So again we will find out the value of the slope and multiply that with the lambda, and then deducting that value from our w2 and we'll get w3. So this is how we are keep on updating our parameters till we get the minimum, till we reach the minimum point. So once we reach this point where our cost is minimized and we have some value of w, let's say could be 20, and our cost is minimized, and that means the slope is no more going to change. So this is the most efficient point in for the predictions. So I hope you guys have understood how gradient descent work. So these are the three takeaways that we should keep in mind. That model will know a way to improve itself. Okay, and this is the gradient descent is the algorithm to minimize the loss, and learning rate determines the size of the step to be taken in particular direction. So these are the key takeaways that we should know how gradient descent works and what does it mean. So now let's quickly move to the practical implementation of gradient descent. Okay guys, so let's now move to the coding part, practical implementation of gradient descent. So here you guys can see I have imported the NumPy library and then defining the gradient descent function. Uh, I'm initializing the value of my parameters m and b equal to 0. So I'm starting with by taking the value 0 initially, and for 10,000 iterations, n is the length of my training dataset and learning rate is 0.001. So I'm running a loop. Uh, so this is running a loop over my 10,000 iterations. So this is my model y predicted y equals to m into x plus b. Then this is my cost function, which is 1 by n into summation of the square values of y minus y predicted. And this is the derivative of m, and this is the derivative of b. Then here I am updating the values of m and b. Then print the values of m and b along with the cost value of cost and the iteration. So let's run this function. These are just random numbers I have taken for x and y. So so these uh, so these are the iterations. So for different iterations, you can see the cost value, which is keep on reducing. The cost values keep on reducing for different combinations of m and b. And on the last iteration, my cost value is 0.006, which is minimum for the value of m 1.97 and b 0.098. So you guys can just try with different combinations of values, and for different combinations of learning rate. You can take it as 0. Here I have taken 0.001. You can take it as 0.0001 or 0.01, 0.05, or say 0.1. So you can take any value and test it out, and you can iterate over 1,000 records, 100 records. So you can just experiment yourself. Okay, I hope you guys have understood. So do let me know if you like this video and you have understood, whether you have understood the gradient descent algorithm or not. So comment below in the comment section. Thank you. Bye bye. Take care.